Hello guys, welcome again. I believe you have been waiting for this unboxing video for quite long time. Same like me. This package been sitting around for too long. I got it from DG Key, which is something very excited inside. We will learn a lot from this box. This box, just to give you a hint and let you guess what's inside. Okay, it's got something with 50k programmable logic element and 1638 kilobits of memory, 5888 kilobits of user flash memory, 18 by 18 multiplier, and 4 PLLS. It's got 64 megabyte of SD RAM with 16-bit data bus. Also got 2 by 20 GPIOs header and also Arduino Uno Rev 3 compatible. It's come with 4-bit resistor network for DAC or digital analog converter that can be used for a VGA, or we can display something on the screen. It's come also with 10 LEDs, 10 slide switches, 2 push buttons, and 6 7 segments. Can you guys guess what is that? Pause the video and let me know down below in the comments. So now, guys, is the time to unbox it, open the box and see what's inside. Let me find my knife. There we go, being my knife. Let's unbox it, guys. So we open it from here and here. Yeah. There we go. So here we have some padding. This is the shipping packing list, and here it is. Ta-da! This is our surprise, guys. It's new dev boards that will add to my collection. It's a DE10-Lite. It's a Intel FPGA University program. Nice, yes. It's a FPGA dev board from Intel. Oh yeah, nice. Here we go. Let me zoom, focus. Yep. If you can see, guys, it's got all the things that you might need to play with the Intel. This is the core, which is the Altera Max 10 from Intel. Got what else? Got accelerometer, SD RAM, the connectors, which is matched to the Arduino Uno, GPIOs. Got USB plaster. Yeah, so this guy is a USB plaster that we use to program and talk to the FPGA. And also got the 6-7 segments. Got 10 switches, light switches, and LEDs. 2 user push buttons. VGA with 4-bit DAC. That's good. Let's go, guys, and unbox the other box, or the final box, to reveal our beast. There it is, guys. So this is our box. Again, the final box that it contains our FPGA dev boards. Let's open it. Got another tape here. Yep. Oh, good, another shield. That's nice. So it's come with the, I believe, the board itself and the USB-B cable. Okay, this is the USB-B cable, and this is our board. Let's see. That's quite good. It's quite small in size and very nice implemented. That's good. Got the what they call the PCB spacers that act as legs, so you can sit down on the bench. That's good. Got some space sometime, because this one is a double side loaded, so it's easy to make any short to the bottom side, especially if you have a messy bench like me. So if you have something underneath, easy to be shorted, but they give you some leg or space, so that's not easy to short it on your bench. Okay, so again, this is our friend, which is the Altera Max 10 from Intel. And here we have our Arduino connector, GPIOs, VGA, 2 user buttons, slide switches, and LEDs, 7 segments, and our USB cluster. That's good. Looks nice. Let me have a close shot for you guys. There it is. Looks nice. I'm excited. We will have a lot of fun with these guys. We will learn a lot of things. Okay. So next, guys, I believe there is a demo code that we can run with a GUI, I believe, on the laptop, so we can do something with the board as it is without doing any extra coding. Okay, so we can maybe have some counters running here, some, I don't know, flippy thinking here when we do change the state of these switches, or even press something here. So yeah, let's see what we can do with the board as it is without doing any coding for the time being. Then we will see what to install and how to move on with this board. Okay guys, so first I will go through this website that I will share with you in the description down below, which is the home web page for the FPGA development board that I have purchased, which is the DE10-Lite. Okay, so this is the board that we have. So you can see here, this is an interview of the board, and yep, just a introduction to the board, yada yada yada, and all these component solutions. That's Altera FPGAs. Okay, we go to the specs. Yep, so here's the specs. This is Max 10 FPGA. This is the part number of the device, and it's comes integrated dual ADC. There's support dedicated analog, blah blah blah. 50K programmable logic element, 1638 kilobit M9K memory, blah blah blah, and all these things. Come with the sensors, accelerometer, and also SDRAM. Got expansion boards and also the Arduino Uno form factor expansion GPIOs. Again, display port also, and come with LDC slide buttons and 7 segments. Okay, power supply for sure, 5 volt DC input, and here's the block diagram of our board. So we can see in the middle is the or the core of this board, which is the Intel Max 10 FPGA. I got the Arduino header, GPIOs, breakout, got clock, got resistors for the VGA, accelerometer, sensor, and also got some buttons, LEDs, sliders, 7 segments, analogs, channels, and SDRAM, as we said, and also the USB cluster, which is the built-in inside the board. USB clusters will usually we use it to download and talk to the FPGA. And for the connectivities, yeah, here they're using, I guess, 2x20 or 2x40, if I'm not mistaken, GPIOs. Let's check. 2x20 GPIO connector. So this is the GPIOs that can be used to any external device. For example, here they connect it to the multi-touch LCD, or they can connect to this looks like camera thingy. Okay, another camera connect to 2x20 this GPIO, or they can utilize the Arduino Uno form factor IOs that can connect any shield that compatible with Arduinos. Okay, here's another LCD can be connected. So we're gonna just go to the layout. I guess layout we already talked about it many times. So yeah, here is the layout. Again, you can see this is the core of the FPGA that we're using. This is SDRAM, USB cluster, VGA, accelerometer, GPIOs, Arduino, and the 2x20. Here's the 5 volts pin header. I'm not sure this is 5 volts in or out. 7 segments, sliders or switches, and LEDs. Got 2 push buttons as well. On the back side, got no interesting things to see. Next, resources. So here's the resources, the most important thing. So from here we can download the manual. This is the one that we will talk about after this. And so here are the daughter boards, or the card that I used to connect it to the main FPGA board, which are, I believe, is one of them, the LCD and camera, etc. And here's the CD-ROM contents that might be useful for us. Okay, later we'll download and see what's inside. Got the control panel, I believe this is for demo, and also the Quartz, which is the most important software that used to develop the what they call the Verilog code, and also be downloaded to the target, which is the FPGA. And here got the cover, I guess top and bottom cover, which is 3D printed, what they call it, 3D print extension thingies. Okay, example design in the CD. I guess this is inside the CD-ROM. Got some examples with a factory default code, SDRAM test in Verilog and iOS 2, VGA pattern, accelerometer, level, and rock. We need to experience this later on. And the control panel looks like this. It looks like very interactive control to communicate with the targets. Again, later we'll try to play with this. And we have the DE10-Lite system builder. And yeah, we've got some educational links to course 1, course 2. Well, so now let's go to the kit contents. And as you can see here, this is the main board, or the main development board, and here is the USB cable, which is A to B USB cable. Next is the demo, and here are the demo video. Later I'll try to share the link with you guys, which is show you the thermal demo source code. I guess this is the source code for the thermal camera, maybe with the LCD, and also the Arduino demo. I believe is some Arduino shield that might connect it to the Arduino compatible IOs. Next is the 3D casing. So as you can see here is the 3D printer files, that 2 pieces, which is the bottom and the top one. I don't think I will go this far to download them or print them, because I can see it's already been covered with the acrylic on top, so should be good for now. And here is where we can order our board, but I already ordered it, so in case you guys want to order, so you can just go to this link. Okay, so here is our board, and also all the accessories, the extensions that might be useful to develop our projects. So now guys, I guess we are good to go to the resources and download the manuals and another demo codes and play with it. So where is the manual? Here it is, user manual. Let's download it. Okay, so here it is. Here is the user manual of our FPGA development board, which is the DE10-Lite. Okay, so let's go through very fast. So here is the contents of this manual. We got some introduction, control, got the use the starter kit, got all the things that we need to know about the development board. Okay, system builder, example, advanced demonstrations, program configuration, flash memory, yada yada yada. Okay, so here's some introduction, what's in the bag that we've seen many times, the system, and also this is a website where we go and see all the rest of the related documents, softwares that are needed for this development boards. Here is the layout. Again, we talk about this again and again. Nothing new. Here's the back side. This is the FPGA device. This is all the, or most of the points that we need to know. Okay, so this is the part number of the FPGA we're working on. We got the ADC channels, I guess 8 channels. With dual function pins. I'm not sure what that means. Need to study more about this. Got 50K programmable, yada yada for PLL and etc. So we're going on configuration. Go on board USB plus. It's good. So this helps us to download the code into the target. Got the memories, 46 Memory connectors got 2 by 20 GB I/O in addition to the Arduino Uno 3 connectors. Got display, got 4-bit resistor DAC. This is the VGA, and also I believe got the 7 segments. Yes, got LEDs, light switches, push buttons, power 5 volts as usual from the USB. And here's the block diagram. This is our target, as you say. Got the ADC. I get what else? This is the plaster. Okay, this is the plaster interface that used to download the code into the target, which is the Max 10. We got the XTALOS clock. Got the SDRAM, accelerometer, and also a resistor divider for the VGA. Got the connectors, buttons, and debouncing these circuits, sliding switch, LED, 7 segments. This is all on the board already implemented. For help, blah blah blah, visit this, call this, where, email that one. I'm not interested. Control panel. Control panel, yeah, the other control panels or utility tools. I guess there's some control panel inside the CD, okay, that we need to download online, which is free of installation. I guess it's just on plug and play. I mean, just like click on it, will auto run for some things and later need to experience it. Yeah, and download the 30 bits folder, pin, blah blah blah. And so this is instructions how to download. I guess is the Quartz Prime installation. This is the software where we will develop the firmware for the FPGA. Execute the DLI, blah 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 blah. This is later we'll check. So the control panel is now ready and ready to use. So I guess the control panel will be like this. So we have like some sub menus like LED, 7 segment switches, VGA, blah blah blah. Okay, so here we give you a kind of nice details that we might need it later to play with the board. Okay, so here they even choose the LED, we'll show the LED. I'm sure they can like toggle on off each one of them, or light on, or turn off all. What else? Now I guess the same segment also you can set the digits that you want to display on the 7 segments. Sliders, oh no, this is not sliders, this is the push buttons and the sliders. Yeah, this is all the buttons. So we have 2 group of switches. You got the push buttons and sliders, and from here also you can control them. SDRAM. Here we can see if we need to read, write all the addresses, which is standard memory thingy. Okay, accelerometer is kind of important. Okay, so here we go. So you can see the level of the board. I believe if we twist the board in any angle, we can see these bubbles are moving to indicate that the accelerometer is functioning. VGA, yeah. So from the VGA, we can select which pattern we want to display. I believe from here got some different patterns that we need to send to the VGA. Overall structure of the control panel, yeah, we're talking about this, all these interfaces. Okay, let's go fast. Configuration of nice VGA, blah blah blah. So this is the JTAG chain on the board. So again, as we said, this is the Quartz. This is the software we need to download, so it can write the code for the Altera or the target of anyway the FPGA, and we have the USB plus circuit which is already implemented in the board. And yeah, here's the software configuration to talk to the target, blah blah blah. Then we use the USB plus that been detected, maybe later see how, then auto detect, yeah. Then it did delete the device which is 10M50DA. Okay, here's the Altera device. This one all guys we will learn together later in the next videos, but this video just to go through the manual and see what we can get on. Internal configuration, okay. Status LED, so you got about 4 LEDs here. Yep, D1, D2, D3, D4s. So it will show you the descriptions of every LED. Okay, so illuminate when on the board USB plus is working, that bit is successfully configured, power active, system okay. Clock warning: do not modify the clock settings, incorrect setting and system not work. Okay, thanks a lot. So they use 24 megahertz for here. Okay, so what next? Using a push button. So yeah, push buttons with all the debouncing circuitries here. Yep. Here they show you it's connected to which I/O. That's good. Where's the I/O? I guess this is the FPGA pin number. Okay, so it's mean key number 0 is connected B8, key 1 A7. And we have again, I guess, Schmidt triggers. I believe this is Schmidt triggers, if I'm not mistaken. That's good. User-defined switches. These are sliders. Again, sliders that will give you all the I/Os from the PGA that been connected to that sliders. Okay, LEDs, same. It's just straightforward LEDs with the probe resistors. So again, here are the pin outs that been connected to. 7 segments, same. Here are the 7 segments I/Os. Okay. And here is our 2x20 connector or pin header. Okay, so here we'll show you all the, I believe, the pin numbers that been addressed to FPGA. Okay, so here is it, the signal name and also FPGA, and the descriptors go to the which pin on the connector or 220 connector. Okay, and here is the FPGA pins. That's cool. Using Arduino Uno 3 expansion header. Okay, here we go. So this is the expansion that's Arduino compatible. Yep, and here is again the pins of the FPGA and also the pins of the Arduino, so it will show you which one go where. Analog digital converter. There we go. So we have about 6 channels. Yep, 6 channels ADCs. I believe got more, but we'll experience this later anyway. VGA, yeah, we'll show you all the VGAs networks. Yep, this is the sync signals, blah blah blah, and also the FPGA pin out. That's nice, it's quite good. And here again, regarding the SRAM, it will show you all the signals that we use to control and talk to the SRAM, and also our FPGA IOs. That's cool. Now we talk about the accelerometers. Accelerometer, yep, we have this ADXL345. Okay, and here are the signals that we use to talk to it. Okay, I believe is I2C, because you can see here there's the pull-up resistors. Yeah, so we have SCL, SDA, serial data, serial clock, and here are the pins. Cool. Introduction to what? Oh, as a system builder, they give us introduction. I believe this is the general design flow, yada yada yada, using this builder. Yep. These guys all we will talk about it in details in the future videos. GBIO expansions, yep. Project setting management. Then generate. Oh, I guess after we generate it, will generate some these files to us that are pre-loaded with all the settings that we done previously. Yes, example advanced demonstrations, installation of demonstration. Okay, the quarters is latest require the demonstration support D10 device. Okay, no problem. Factory configuration, demonstration file location. Okay, demonstration setup and installation. Okay, factory configuration. That's in your. Okay, so we will try to practice that all together, guys. Demonstration setup. Okay. What else we get? Exam test in Verilog. Okay, we'll see what is that later. Demonstration of source code, demonstration of blah blah blah, LED, status indicators, VGA patterns, yeah, and all the waveforms that we might need it. Demonstration patch file, demonstration setup, yeah. These all we will come across it again in the future. ADC measurement, yes, this also might be quite useful, because most of the time we might have some ADC signals from the outside that we might need to read it. Yeah, so he'll show you all the things that we need. Then here we connect to, what is it? Oh, voltage looks like maybe is a potentiometer, could be a potentiometer. It's not clear here, but looks like since we have a voltage here, voltage from 0 to 3.28, so it looks like maybe a potentiometer. I don't know, could be. Yeah, measure channel voltage, so it could be anyway. Yeah, so here's what position D10 on board. We'll see what this do later. Internal configuration. Okay, we got images. Is that what I understand? Like if we power up, then the sample boot pin, it will detect whether, or it will decide whether we go to the boot select 1, boot select 0. So we have like two images or two files, two code files. So if one being corrupted, so we have another file that's been already guarantee is working to go through. For example, here to say, oh, this one got corrupted, will go to here then. To continue the configuration and power up the device. Otherwise, if we have only one path, then this path is corrupted, then I cannot power up the device anymore. So this way we can guarantee that at least one image is up to date and correct to be loaded. We talk about this more in the future using compressing image. Yeah. Okay, so I guess that's it. This one you need to practice it in hand to learn all these configurations and also the coding to play with the device. Yeah, so here's the clock settings. Okay, so here guys, I want to go through very fast with you because we still have too many things to do and I don't want to make the video too long for you guys, otherwise we'll be kind of bored. So yeah, additional information if you want help, this email, website, blah blah blah. And that's it, we have finished it. So this is the revision history of the document. So yep guys, so let's see what we can do next, whether we can maybe play with a bit of demo, we see whether it's working or no, then we continue from there. Okay, so guys, as you can see here, let me select the tool. So you can see here from the control panel, if you want to open the demo application, we need to go to the where tools control panel in the CD, sorry, and the CD or the folder that we downloaded from the link up there, and it's free installation, blah blah blah. Just go to the whole folder, copy, then we need to launch this application. So I already launched it and here it is. So this is our demo application. And here I already connected the target board or the DE10-Lite FPGA demonstration board to the computer, and you see this is how it looks like the first time when we power up. There's flashy LEDs and also 7-segment displaying something. So now I believe all what we can do is hit connect, so the demo tool will start to link to the board. So now is connected, I believe. Yeah, if you see here is connected in green, and here we can see we have 6 departments, which LED, memory, 7 segments, accelerometer, switches, and VGAs. And this button is to connect and disconnect. So here we are already in the LED section. So you can see here we have how many LEDs? I guess is in 8 or 10. 0 to 9. Yeah, is it 10 LEDs? So I believe, yeah, from here, as you can see, we can toggle and select and toggle any LEDs we want to activate them. Okay, or we can just light them all off or all on, and light all on or off. So this is the LEDs part, and also we can see here it will highlight to you, okay, this is the LED parts. Can we select here? Oh, sorry. Can we select different parts? No. Okay, so let's go to 7 segments. 7 segment again, here we go. You see we're displaying some numbers here. So if we go to A, here we go, A, B, C, D, E, F. This is a hexa for sure because it's 7 segments. So 0, 1, 2, 3, 4, 5, 6, 7, blah, blah, blah. So here we can dial in any number, which is again just for the sake of demonstration or to show off the power of the board. Accelerometer, yep. So here's the accelerometer readings. So we have X and Y. So now if I move it, I expect, yes, the ball is moving, displaying the position of the board. So if I bring it like this all the way up in the X direction, all the way up in or the other direction on the X, yeah, that's good. Accelerometer working. Switches. There we go. So we have two tactile switches and about 10 sliders. Okay. So if I press, yes, I press key 1. We can see here a very tiny animation. It's showing that the button being pressed, and now I will slide some switches. Yes. So you can see here I have slided switch number 0, 2, 7, and 9. Yep. Switch is okay. And what else? Memory. Yeah, let's try the memory. So here is the memory, so we can read, write. There we go. So we are reading from this address. What is it? So this is the address is 00. We can read, we can write, we can do all these funny things. Write file to memory, load file from memory, the input 0 length. Oh yeah, I need to find the length. I'm not sure the length. Let's say put 110. Read. Here we go. So we can save it. I guess we already like read it from the memory. Start from this address with a length of 10, so we can save it later. Okay. What else we can do? VGA for sure need to connect to the VGA to display these different patterns. So yeah, either all red, blue, black, white, or red scale, blue scale, and all these things. So yeah, this is the demo, guys, for the FPGA development boards. Okay, so now if I disconnect again, I believe it will disconnect from the target, and yeah, now it's not linked anymore. So whenever I do, it's not connected. Yep, need to connect back again to gain back the functionality, or connect back to the board. Yes, then now here we go. I can control the board again. So yeah, so I guess that's it for this video. I don't want to make it longer. So yeah, so we already have unbox it, we explore the board together, and we go through all the documentation, websites, and we have come across the very simple small demo to explore all the functionalities that are available inside the board. So I guess that's it, guys. So I hope you have learned something from this video. I don't want to make it longer, so I'll just release it up to here. So in the future, we will try to learn more and do more, let's say, with the LEDs, memory management, 7 segments, and all the others peripherals that are attached to the FPGA. Yeah, so happy learning, and see you soon in the next tutorial.